When I choose a microphone, one of my first decisions is, do I want a dynamic microphone or a condenser microphone? One of them is rugged and reliable and has a smooth, rich sound character. The other one is detailed, articulate, and can hear every fine detail in the performance and every little tiny noise in the room. Both are great choices depending upon your usage situation. And so if you've had this question and you're wondering which microphone should I pick, or if you're just curious about how these microphones work, how they do their job, well, you've come to the right place, because I'm going to break down the differences between condenser microphones and dynamic microphones and tell you all the places where I would use these mics and why I would make a particular choice. And I'll also go into how these microphones actually function, so you have a better understanding of the two different main types of microphones and where they're best employed. Now, of course, there are other types of microphones available as well, such as ribbon microphones or carbon pile microphones, but those are severe outliers. Now, the mics I have up here today are a Tank 1 from Fine, it's a dynamic mic, and an Audio-Technica AT2020 condenser microphone. I'm not doing a direct head-to-head comparison between these two mics, although you will be listening to both of them. But I chose these two because they are about $100 a piece, so they are relatively comparable to each other price-wise. So you can kind of get a comparison to the performance between these two at that price range. Let's talk about the dynamic microphone. Dynamic microphones are relatively rugged in that you can probably drop it on the floor a couple of times and it'll still keep working. Now, all microphones are precision devices and shouldn't be dropped on the floor, but the ruggedness of dynamic microphones makes them suitable for situations such as use on band stages or in places where they might get banged around a little bit, thrown into a desk drawer, and you can probably count on that microphone still working afterwards. Dynamic microphones can also be left out in the studio, and they'll probably work just fine. A little bit of dust and dirt in the atmosphere is probably not going to have a major impact on a dynamic microphone. Now, of course, all microphones should be treated very gently with care because they are precision devices, but dynamic microphones, pretty tough. Dynamic microphones are also good for loud sound sources. So if I'm going to close mic a drum kit and have a microphone just a few inches off of the drum head, or a microphone inside of the kick drum, or if I'm trying to record some machinery operating that's making loud noises, or perhaps recording a firearm going off, a dynamic microphone would be my choice because they can handle, generally speaking, very high sound pressure level without damage. The other thing with the dynamic microphone is that, in general, they tend to be a better choice if you're looking for a microphone that is highly directional. Now, of course, microphones come in different patterns. Some are omnidirectional, some are cardioid, and some are hypercardioid. And the cardioid class of microphones mean that they are sensitive to noises coming into the front, but not so much off the side and the rear. And so the pattern of these microphones allows the mic to reject unwanted background sounds effectively. Now, of course, with condenser microphones, we have those properties as well, where they are directional, like dynamic mics. But generally speaking, in broad terms, usually I find that condenser microphones are not quite as directional as some dynamics. There are some dynamic microphones with very tight patterns, such as this Tank 1. So as long as I'm in front of it, it picks me up just great. But when I get off to the side or rear, it gets severely attenuated. And that's great for knocking down some of the extraneous background noise that I don't want to get picked up and put into my production. Now, the dynamic microphone works with the same principle as a loudspeaker. In fact, it's almost identical to a loudspeaker, but in miniature form and, of course, optimized for sound pickup. In a loudspeaker, we have a a cone with a coil of wire attached, mounted in front of a magnet. And when we put energy into that coil, it creates a magnetic field which pushes and pulls against the magnet inside of the speaker. And so that makes the cone move forwards and back. In a dynamic microphone, we have the same kind of assembly on a miniature scale, where we have a diaphragm instead of a cone. Diaphragm tends to be something like a more or less flat piece of mylar. And attached to that diaphragm is a very lightweight coil of wire. And this whole diaphragm assembly is suspended close to a permanent magnet. And it operates in the reverse of a loudspeaker, which is when the diaphragm vibrates, when sound hits it, when I speak into the microphone and vibrate the diaphragm, I'm moving that coil of wire through the magnetic field of the magnet that is mounted nearby. And the physics of that causes a current to start flowing through the wire. And the current is proportional to the movement of the diaphragm, and so the electrical energy that comes off of the wires from that lightweight coil contain the audio that we're trying to pick up. Now, there's some other passive components inside of the microphone typically, such as a transformer, which takes that small signal coming off the coil and boosts the voltage up a little bit, reduces the current, but boosts up the voltage, making the signal a little stronger and easier for us to process at our audio interface. There may be some other passive components like a mute switch, maybe a simple filter for a low-cut filter. But aside from that, there are no active electronics inside of a dynamic microphone. It's a completely electromechanical device. And of course, the tolerances are very tight, so it's a precision device, and for that reason we don't want to drop it on the floor or bang it around too much, because that could disturb the alignment of the parts that allow the diaphragm to move freely. But there's no electronics inside of a dynamic microphone, unless, of course, the microphone has got a USB output on it, and in that case, there's some USB digital electronics inside the mic. But just as a standard mic talking to a standard audio interface over a 3-pin connector, it's just an electromechanical device. And because all of the electricity coming out of the microphone is generated magnetically just from the sound coming in, there's not a lot of energy there. Of course, if you put the microphone in front of an extremely loud sound source, like inside of a kick drum or right in front of a loud guitar amp, you'll get a pretty strong signal out of the mic. But if the mic is listening to something that's fairly quiet, such as just me standing here talking to it, the signal level coming out of a dynamic mic is going to be fairly low. And so that means that on your audio interface or your mic preamp, you may have to have the gain turned up pretty high. There are some dynamic microphones that have lower than typical output, such as the Audix OM7 stage microphone or the Shure SM7 broadcast podcast microphone, which are known for having notoriously low levels of output. Doesn't mean they're bad microphones, they sound great, they just don't have a lot of signal output. And for those type of microphones, depending upon the audio interface that you use, you may find yourself wanting to add a inline microphone preamplifier on the mic cable to boost the signal up enough so that your audio interface has enough gain to properly work with that microphone and give you a large enough signal that you can process easily. So dynamic microphones are an industry workhorse. They generally represent pretty good value, meaning that you can get a good quality dynamic microphone for not a whole bunch of money. And they've been around for a real long time. And until recent decades, they were for sure the most popular types of microphones. A few decades ago, getting a high-quality condenser microphone was a pretty expensive adventure. Now, due to recent advances in precision manufacturing, we've been able to produce condenser microphones that are quite good at reasonable price points. So the market is shifting a little bit. But if you look at bands on stage, almost all of their microphones will be dynamic microphones. A place where dynamic microphones fall a bit short of condenser microphones is in terms of accuracy of high-frequency pickup. The diaphragm inside of a dynamic microphone has a coil of wire attached to it. And so that means the diaphragm inside of this microphone is going to be heavier than the diaphragm on a condenser mic. And the heavier diaphragm is a little harder to move. And so that means this is not going to be quite as sensitive to super quiet, minuscule sounds. And it's not going to reproduce really high frequency sounds that require that diaphragm to move extremely quickly. And so for applications such as picking up cymbals on a drum kit, or harpsichord, which has a lot of high frequency, detailed energy in it, or for picking up all of the extremely minor nuances of somebody's voice, the dynamic microphone may fall short of what a condenser microphone can do. In summary, dynamic mics are great mics. They're commonly in use. Most of the mics on a rock band stage are going to be dynamic mics. They're often used for podcasting and broadcasting. They're great in situations where you want to reject excess background noise. So for things like this YouTube video where I'm recording in a less than acoustically perfect environment, a dynamic mic is a pretty good choice because it helps attenuate some of the other sounds that are happening in the background. And of course, there's a wide range of microphones out there with different sound signatures. So you have a big choice as to just exactly which dynamic mic you want and what sound character it has. If you check out the link below the video of my recommended equipment, you'll see a bunch of microphones that I use and I like. And I also have a playlist of microphones and microphone reviews. And so you can explore that for more content on specific microphone models. Let's take a look at the condenser microphone. A condenser microphone operates on an entirely different principle than the dynamic microphone. The condenser microphone is sometimes called a capacitor microphone by us old guys because the element in it is actually a capacitor. Now, a capacitor is an electronic component that can store and hold an electrical charge. You've probably had the experience of where you've walked over a carpet in a room, reached out and touched a doorknob, which was attached to the grounded door frame, and got an electrical zap out of it. In that situation, you are acting as part of a capacitor. As you walked across that carpet, you picked up an electrical charge which your body held, and then when we reach out and grab the doorknob, that charge is dissipated and we feel it as a zap. And so capacitors can store up and hold an electrical charge. And capacitors are typically made up of two conductive pieces of material, like two metal plates with an insulator in between. So it's a sandwich of material, of a conductive plate, insulator, and another conductive plate. And the element inside of a capacitor or condenser microphone is exactly that. There's a backing plate, an air gap, which forms an insulator, and then a front diaphragm plate, which is very lightweight, like a thin piece of mylar that is covered in metal, usually something like a very fine coating of gold. And there's no coil or any other weight attached to it, so it's just a very thin, lightweight piece of material that can move easily when sound hits it, making a condenser microphone very sensitive to sound. And it also makes the microphone relatively delicate. If you drop that on the floor, there's a chance that you're going to misalign parts or break that extremely delicate element and the microphone will fail. These microphones are also somewhat susceptible to dust and dirt and pollution in the air. If the microphone gets too much dirt in terms of air pollution, microscopic particles in the air attached to that front plate, it can affect how electrically conductive it is, it can affect how easily the plate moves, and it can impact the performance of the microphone. So for best results, we want to treat our condenser microphones with quite a bit of care. We don't want to bang them around or drop them. I don't like to leave them sitting out in the atmosphere in the studio unprotected for month after month. I like to put them away in the case or maybe put a sock over the microphone so it doesn't get pollution from the air getting stuck onto the capacitive element. And the element requires a charge to operate. Let me give you an analogy as to how the microphone works. Let's imagine a balloon, and the balloon is the capacitive element. The front side of the balloon is one side of it, the back side is the other conductive side, and inside the balloon, the air is the insulator. And so we could blow up the balloon, and the balloon fills up with some air pressure in it. We've charged the balloon as we've electrically charged the capacitor. Now we could put a super sensitive pressure meter on the balloon. So once we blow up the balloon and it's got some air pressure inside of it, we could measure what that air pressure is. Then if I was to take that blown up balloon with the pressure meter on it and squeeze it together, well, the pressure is going to go up. And so we can, using a pressure meter, tell how hard the balloon is getting squeezed. So then I could take that balloon with the pressure meter attached, and I could stick it on a wall, and then I could speak and talk right at the balloon. And the sound waves coming from my voice are going to hit the balloon and cause it to very microscopically get squeezed every time I speak. And the balloon is going to vibrate just a little bit in accordance with my voice talking. And I could measure those vibrations on the pressure meter. And so that's how a condenser microphone works. Now, instead of using air pressure, we're using electricity, but we charge up that element, and the minute changes in the position of the diaphragm cause very minor electrical changes to come out that can be sensed and amplified and processed by our gear. Now, of course, for that kind of microphone to work, we have to charge up the element, which requires some power. So with condenser microphones, some of them have a place for a battery, which provides just a little bit of electrical power to charge up the system. Most microphones rely upon what's called phantom power, which is a low-level DC signal coming from your audio interface to power up the microphone. Now, of course, the signals that are coming off of the element are extraordinarily small. And so inside of the microphone, in addition to charging up the element, we also have to have a little bit of electronic circuitry to suss out that signal and boost it up to a level that we can work with easily with our gear. The microphone designers, since they're building an amplifier stage into the microphone, could build that amplifier to have whatever amount of gain that they want. And so they make a decision to provide a fairly strong and powerful output signal from the microphone. So because of that, with a condenser microphone, you generally have a larger, stronger output signal than you would from a dynamic microphone. So if you have quieter sound sources, you get a stronger signal out of the condenser microphone, and you don't need quite as much gain at your mixer or your audio interface. Now, because there is some active electronics inside of the microphone, there is a gain stage in it, we know that every audio amplifier of any kind out there has some hiss and noise real quietly down in the noise floor. And so with condenser microphones, one of the issues that we do have is that all of them exhibit a little bit of hiss in the background. And this is called self-noise, and that's a common specification of the microphone, is how much self-noise does the microphone have. In most applications, I don't worry about that at all. The noise is so quiet, so far down there compared to my signal that I'm trying to pick up that it's negligible, not an issue. But there are some applications where I do pay attention to that spec. For example, if I was going to use a microphone for doing a quiet recording of nature, I want to hear the chirping frogs in the pond at night. And that's really quiet. And when dealing with super quiet signals like that, it becomes important to start looking at the noise specifications of the microphone and your audio interface to make sure that the signals you're picking up are going to be far enough above the noise floor that it'll end up being a good recording. And so if I was looking for a microphone for doing ambient type recordings of really quiet stuff, I'd prefer to see a microphone with a self-noise spec of maybe 12 dB as opposed to one with 20 dB. One of the things I mentioned about dynamic microphones is they can be found in very tight patterns. And same thing with condenser microphones. Some have wide patterns and some have narrower patterns. But speaking in very general terms, I usually find that condenser microphones are not quite as directional as dynamic microphones are. And because they're not quite as directional, usually, and they have the ability to very cleanly and accurately pick up extreme high frequencies, if I'm choosing a condenser microphone for a live microphone on stage, I expect that mic is probably going to do a great job of picking up all of the little details in that person's voice. But condenser microphones on a live stage also make me consider that I just might have a little bit more of a propensity for this microphone to have feedback from the sound system, where the microphone hears the sound coming out of the loudspeakers from the amplification system, and that goes into the microphone, which then gets amplified back out the speakers, and you get this feedback effect where the system squeals and everybody gets unhappy. With really great singers, then you want to highlight all of the minor nuances of their voice. Sometimes you will choose a condenser live vocal mic. But in a recording situation in a studio, large diaphragm condenser microphones are the way that most projects are done because they give great vocal detail. And they have great detail for things like harpsichords or drum cymbals or other classical instruments where you want to pick up all of the fine little detail. But as I've mentioned, they're relatively delicate, and so they're not a good choice for places where you're going to deal with extremely loud sounds. For example, putting a condenser microphone right by a snare drum head, that might be too much for that delicate element, and you could possibly damage the element in the microphone with a sound source that loud, or for use inside of a kick drum, for example. Now, of course, I'm talking in general terms. There are certain mic models that are exceptions. For example, Shure has the SM91, which is a kick drum microphone. That's a boundary microphone style that is designed to slide right into the kick drum. And it's a condenser mic, and it works great in that application. And it is specifically engineered for that sort of duty. So there's individual exceptions, but we're talking in a general sort of way. So I hope that gives you some guidance as to which microphone you want to choose. Condenser microphones are great if you're looking for fine detail and your understanding of their delicate handling and the care requirements to properly take care of a condenser microphone and keep it in good shape. They also require phantom power from your audio interface. Most interfaces provide that. If you happen to have a piece of equipment that does not, you can get an inline adapter which plugs into the microphone cable to provide the power necessary to run the mic. If you're interested in doing a deep dive on phantom power, I've got a video on that topic which I invite you to explore. Dynamic microphones, on the other hand, are rugged and reliable and have a nice smooth sound character to them, and they're an industry workhorse. And if you're interested in specific microphones, I've got a playlist of microphones and microphone reviews that I encourage you to check out. Underneath the video, I've got my recommended equipment list where I have a whole bunch of microphones that I've used and have enjoyed and that you can check out. And I encourage your comments about which microphones have worked well for you and what your choices have been that have been successful. And I appreciate you hanging around with me for a bit to watch the video. If you got some value out of it, which I assume you did since you stayed to the end, I'd appreciate if you'd reach down and click that thumbs up to let YouTube know that this is a good one and that they should promote it more. Thanks for hanging out with me for a bit, and I will catch you again soon. on another upcoming episode.